The Deepwater Horizon blowout preventer, commonly known as a BOP, stood nearly 6 stories tall, weighing over 300 tons, and was designed to hold well pressures up to 15,000 psi. The Horizon BOP stack was manufactured by Cameron in 2001 and equipped with 2 annular BOPs, upper and lower, and 5 ram BOPs, consisting of a blind shear ram, a casing shear ram, 2 variable bore rams, and a test ram at the bottom, which was requested by BP to expedite pressure testing of the BOP. The blind shear ram, variable bore rams, and test ram were fitted with Cameron standard ram bonnets containing the actuating pistons and ST locks designed to hold the ram preventers closed in the event of a loss of pressure. A 5.5-inch diameter drill pipe passed through the BOP on the day of the incident. Each joint was roughly 46 feet long, with 18-inch long threaded connections or tool joints on each end of the pipe. A tool joint was intentionally positioned in the BOP to properly space the tubular section through the ram BOP during the well abandonment procedures. As well pressure pushed the drill pipe upward in the BOP, the drill pipe bowed. At roughly 9:43 p.m. local time, the crew of the Deepwater Horizon activated the upper annular, a steel-reinforced rubber donut device that squeezes tight around any pipe located in the BOP. The annular closed around the tool joint and drill pipe. The increasing fluid velocity eroded the rubber annular closing element, the steel drill pipe, and the steel tool joint, preventing the annular BOP from sealing tight. A close-up of the actual tool joint shows the rapid and complete degradation caused by the swift movement of fluids acting like a water jet cutting device, slicing through the metal and creating pathways for continued upward flow of fluid in the space between the steel pipe and rubber annular closing element. At approximately 9:46 p.m., roughly 3 minutes before the first explosion, the riser evacuated onto the drill floor, discharging a combination of expanding gas, drilling mud, and seawater onto the decks. Seconds later, the drill crew activated both the upper and lower variable bore rams. The variable bore rams are engineered to seal around variable diameters of drill pipe, from 3.5 inches to 6 5/8 inches in diameter. With the activation of the variable bore pipe rams, the well flow was secured, but pressure continued to build within the drill pipe itself, and hydrocarbons and gas that had already entered the riser above the blowout preventer continued to expand and exhaust to the rig. Shortly after the variable bore rams were engaged, gas from the well dispersed and mixed with air. The gas mixture was ingested by the running engines, causing them to overspeed and shut down. Power on the rig was then lost, resulting in a blackout and loss of dynamic positioning capability. The first explosion on board the Deepwater Horizon occurred just seconds later. As pressure increased, the drill pipe ruptured where the steel had been severely washed away and eroded. Wellbore fluids again flowed upward in the riser to the surface. Without power, the rig was no longer able to remain in position. The rig drifted off location, stretching the drill pipe held in the BOP. Within minutes, the drill pipe was pulled apart, nearly at the same point above the tool joint where the initial rupture had occurred. Close examination of the actual severed drill pipe recovered from the Deepwater Horizon BOP after the incident shows the effect that high-pressure flow had in eroding the pipe, as well as the location where the pipe was pulled apart. The Horizon BOP was equipped with a built-in battery-powered automatic mode function device, commonly known as the AMF. The purpose of the AMF is to activate the blind shear rams under a scenario in which hydraulic pressure and electric power are lost from the surface, such as a riser failure or other event where the BOP cannot be operated from the drilling rig. The exact time when the AMF activated, either before or after the drill pipe was pulled apart, is unknown. However, the AMF did what it was designed to do: actuate the shear rams, then set the ST locks. Forensic analysis indicates that the shear rams were unable to move all the bowed drill pipe into the shearing blades. Part of the bowed drill pipe was held for a period by the flat outer faces of the ram blocks. When released, the top section of the pipe was propelled upward and was later found resting on the top of the upper annular. Meanwhile, wellbore fluids continued flowing at high pressure through the pipe. The rubber seals on each side of the shear rams were washed out, allowing the well to continue to flow around the sides of the blind shear rams. In this close-up view of the shear ram, we see how the high-velocity fluids from the severed drill pipe flowed around the ram blocks, eroding the rubber side packers and cutting into the body of the BOP, even as the core mechanisms of the BOP closed as designed. As the close-up moves across the face of the ram, significant erosion can be seen on both sides of the ram block. At this time, the drill floor was on fire. The drill line was weakened, and the traveling block, best described as an arrangement of pulleys through which the drill pipe is raised and lowered, fell down through the derrick and onto the rig floor. Subsequently, the drill pipe dropped and came to rest on top of the upper annular BOP. Roughly 36 hours later, the Deepwater Horizon sank into the Gulf of Mexico, bending the riser on its way to the sea floor and kinking it just above the BOP.